Okay, now we are on our level 4 video. So numbers 1, 2, 3 say to find the measure of each labeled angle. So for number 1, we are trying to find the measure of angle E, which is this whole thing here. Well, all of these angles create a full circle. A full circle adds up to 360 degrees. So to find the measure of angle E, notice I'm putting M angle E. That means the measure of angle E. And when you're finding the amount of degrees an angle is, you do need this M here. That stands for the measure of angle E. We would do 360 degrees minus 122 degrees. So 360 minus 122 gives us that the measure of angle E is equal to 238 degrees. Next one, I can assume, this is the only thing I can assume in geometry, that this is a straight line. And a straight line or a straight angle adds up to 180 degrees. So to find the measure of angle A, I could do 180 degrees minus that 145 degree angle. So 180 minus 145 would give us that the measure of angle A is equal to 35 degrees. All right, number 3. Again, I can assume straight lines, so I can assume that this line here is straight. So angle D and the 40-degree angle should add up to 180 degrees. So the measure of angle D would be equal to 180 minus 40. The measure of angle D, is equal to 140 degrees. Well, that 140 degree or that 40 degree angle and angle B are also creating a straight line. They're a linear pair. Remember, linear pair are two angles that create a straight line. They're also supplementary because they're two angles that form a straight line. And so since angle B and the 40 degree angle also create a straight line, that would mean that the measure of angle B would also be 140 degrees, so we don't have to do work for that. And then if angle D or angle B, does not matter, if angle B is 140 degrees, well, angle B and angle C create a straight line, so that would mean that the measure of angle C would be 40 degrees. All right, moving on. It says to draw a picture for each of the following situations. So I have C is a point in the interior of angle AOB. So I'm going to draw angle AOB. When I say C is in the interior, it means C is somewhere inside of this angle. And if I connect O to C, then that ray cuts the angle. Not into two congruent pieces, it did not say that, but it cuts the angle somewhere. So then it says the measure of angle AOC plus the measure of angle COB would equal the measure of angle AOB. What this is called is the angle addition postulate. And basically what it means is if I take a part of a whole angle plus the other part of that whole angle, and I add it together, it will equal the whole angle. For number 5, it says if C is between A and B. So what that means is if we have point C in between point A and B, so here we have A and B, C is somewhere in between. It does not say that C is the midpoint. Let's say C is right here. Then, if I take segment AC, which I'm not going to do the segment bar because I'm going to talk about the length of AC. If I take the length of AC plus the length of CB, that would equal the length of the whole segment AB. This is called the segment addition postulate. So we're going to use the angle addition postulate and the segment addition postulate below. So for number 6, D is on the interior of angle ABC. So let's draw ourselves a picture. Let's draw angle ABC. And D is somewhere in that interior. It does not say that D is a bisector, so it's not. If the measure of angle ABD, which is this one here, is 37 degrees, and the measure of angle ABC, which is the whole angle, is 84 degrees, we want to find the measure of angle DBC. So if you take the measure of angle ABD plus the measure of angle DBC, that should give you the whole angle, angle ABC, which is 84 degrees. So to find the measure of angle BBC, we would do the whole angle, 84 degrees, minus the other part of that whole angle, 37 degrees. So an 84 minus a 37 comes out to be 47 degrees. All right, number 7. QS bisects angle PQR. So what that means is we have angle PQR. Let's draw that. A reminder that the middle letter is always your vertex of your angle. And QS bisects that angle. What that means is that it cuts this angle in half. So remember how we represent two equal halves is we draw these arcs in. We know that the measure of angle PQR, which is this whole angle, is 3x minus 4. And the measure of angle, sorry, I should have put PQ. That was a typo. On yours, it is corrected. This should be PQS. The measure of angle PQS is 3x minus 4 degrees. And the measure of angle PQR, which is the whole angle, is x squared degrees. Well, since angle PQS and angle SQR are congruent, that means that we can label angle SQR 3x minus 4 degrees as well. And now I'm going to use the angle addition postulate. I would take the measure of angle PQS, which is 3x minus 4. I would add it to the measure of angle SQR, which is also 3x minus 4. And I will set that equal to my whole angle, which is x squared. Now I'm going to combine like terms. A 3x minus a 3x is a 6x. A negative 4 minus a 4 is a negative 8. Whenever you see an x squared, you should automatically think that this is a quadratic equation. And when we solve quadratic equations, we need to set our quadratic equation equal to 0. So I need to subtract this 6x over to the other side. I also need to add this 8 over to the other side. So now I have it set equal to 0, and I have an x squared minus a 6x plus an 8. I am now going to be using the box method. Split up your x evenly. Two numbers when multiplied together equal a positive 8, but when added together equal a negative 6. That would be a negative 4 and a negative 2. That does not mean that your answers are negative 4 and negative 2, because remember, we do need to set these binomials equal to 0. And then we will set the x minus 4 equal to 0 and solve for x, and the x minus 2 equal to 0 and solve for x. Add 4 to both sides, I get x is equal to 4. Add 2 to both sides, I get x is 2. Now I cannot just accept this answer because if I put these x values into my angles, if one of my angles comes out to be negative, then that means that that x value does not work in your problem. An angle and a segment can never be negative. So we need to make sure that we check both of these answers into our problem, into our figure. So if I put a 2 in for the measure of angle PQS, a 3 times a 2 is a 6, and then minus 4 is a 2, so 2 degrees. That works. So x can be 2. Let's see if 4 works. A 4 times a 3 is a 12. A 12 minus a 4 is an 8. So since that gives you a positive angle measure, that also works. So when it says to find PQS, which this actually should say measure of PQS, you are going to put the 2 and the 4 in, and PQS could actually have 2 different angle measures. It can be 2 degrees or 8 degrees when we put that 2 and that 4 back in. That's your answer. Okay, so the next one, find our S. We are going to use the segment addition postulate. So we take the 5x plus the 3, and that equals your whole segment, which is 2x squared. Now, we see an x squared. This should tell us that this is a quadratic equation, so we need to set this equal to 0. So I'm going to subtract the 5x over, and I'm going to subtract the 3 over. So now I have it set equal to 0. For this quadratic equation, I am going to need to use the x method. In the top of my x is my a times c, so a 2x squared times a negative 3 is a negative 6x squared. In the bottom of my x is my b, which is a negative 5x. Two numbers when multiplied together equal a negative 6x squared, but when added together equal a negative 5x, would be a negative 6x and a 1x. So I have a 0 is equal to a 2x squared minus a 6x plus a 1x minus a 3, grouping my first two terms and my last two terms together. I get a 0 is equal to, my GCF out of my first two terms would be a 2x, and I'm left with an x minus a 3. My GCF out of my next two terms would be a plus 1, and I'm left with an x minus a 3. So my binomials are a 2x plus 1 and an x minus 3. Solving both of those for x, you get x is negative 1/2 and x is positive 3. Now if I put a negative 1/2 in for our s, that gives me a negative side length or segment length, which is not possible, so that cannot be a solution.